radicals. Okay, so some applications for what we've been learning with radicals in the Pythagorean theorem. In your packet, you're asked to find, or to use the Pythagorean theorem to find the area of isosceles triangles. Okay, so let's go ahead and title our next section Pythagorean theorem with isosceles triangles. And I'm going to do an example with you, and then I want you to try it in your packet. Okay? Okay, so let's say we have an isosceles triangle. Remember, an isosceles triangle is a triangle with two congruent sides. And this isosceles triangle has a length of a side that's equal to 7.5 centimeters. This side is also 7.5 centimeters. And the base of this triangle, of this isosceles triangle, is 6 centimeters. And we're asked to find the area of this triangle. Now we know the area of a triangle is equal to half of the base times the height, right? We have the base, but we don't have the height. So what are we going to do? Well, we are going to draw in the height here. And if you notice, when we do that, we get a right triangle on both sides. So they're both right triangles. And we split the base in half. So if this whole thing is 6, this part of the base becomes 3. And then we have a right triangle right here. And we have the length of the hypotenuse of the triangle. We have the length of one of the sides. And then we have this height that we're looking for, which I'll call x. Okay, and we can actually solve for it using the Pythagorean theorem. And we know that the formula for the Pythagorean theorem is a squared plus b squared equals c squared. We know that a is 3, so we're going to do 3 squared. We don't know what b squared is, so I went ahead and did b squared. And c squared is the hypotenuse, so it's 7.5 squared. Okay, or we can write this again as 3 squared plus x squared equals 7.5 squared. Okay, let's go ahead and start simplifying. So 3 squared is equal to 9 plus x squared. 7.5 squared, can't do that on the top of my head, so I'm going to go ahead and use the calculator. So 7.5 squared equals 56.25. Okay, and now in order to solve for x, we have to get x by itself, right? So I'm going to subtract 9 on both sides. So we get x squared equals, and 59.25 minus 9 is equal to 50.25. And to get rid of this square, we have to take the square root. So x is equal to, and let me use the nifty calculator here to do that, square root of 50.25 equals about 7.1. And since our units are centimeters, 7.1, oops, sorry about that, centimeters. Okay, but we're not done yet. We're here to find the area. Okay, so let's use our formula right here. So area is equal to 1/2. We know that the base of the entire triangle is 6. And we just solve for the height of the triangle right here, which was 7.1. Or let's just round it to 7 in this case. And so we have 1/2 times 6 times 7, 42. And half of 42 is equal to 21. So our answer is the area of this triangle is 21 centimeters squared. Okay. So now that you know how to do this and you've seen the example, I want you to turn to page 30 in your packet. Right here. And I think you can do the rest of these problems. Now in the last math section of your packet, you're asked to use your knowledge about Pythagorean theorem and apply it to word problems. So you can title this last section using the Pythagorean theorem to solve word problems. Okay, I'm going to do an example with you, and of course, the rest of the problems that you're going to be required to do are not exactly the same thing, but they're similar, and hopefully this example will give you ways and strategies to solve the word problems that I've assigned you for homework. Okay, so say like we have the problem, or this following problem. What is the longest stick that will fit inside a 24 by 30 by 18-inch box? Okay, well, my first step here is to draw a diagram. So I'm going to go ahead and draw a box here, a 3D box. And okay. So this isn't going to be the neatest box, I'm sorry. Okay, to make it 3D, I'm going to do it like this. And then I'm going to dot so I can see the inside here. Okay, so we're told that it's 24 by 30 by 18, which means that one of the sides right here is 24 inches. And the width of the box is 30 inches, and then the height is 18. And if we look at our box, and if you've ever played around with a box and tried to fit a stick in there, you will soon find out that the longest stick that you can stick in the box is the one that goes from corner to corner diagonally like this. Okay, so I'm going to draw it in with a different color. Let's pick red. Okay, let's try this out. So the stick is going to be from here to there. Okay, alright, let's try that again. That wasn't very straight. From there to there. Okay, that's kind of as good as I can get it. Now, we can't solve for the length of this right away. But what we can do is this. I'm going to switch colors again. Let's pick blue. Okay. So we know this is a rectangular prism right here. And since there's a rectangle for the base, we know that this corner right here is a right angle, excuse me. And if we were to draw this diagonal end, we'd be able to use the Pythagorean theorem to solve this. And then check this out. We have another triangle right here, and since this is a rectangular prism, we also know that the way that this line right here hits the base that is also a right angle. So what we can do is use the Pythagorean theorem, solve for x here, and then given x and given this height right here of 18 inches, we can then solve for this hypotenuse, which I'm going to call y. Okay? So let's do this. So, part 1. Okay? Let's use the Pythagorean theorem. A squared plus b squared equals c squared. Let's make our a 24 inches, so 24 squared, plus, let's make b 30, so 30 squared, equals c squared. But since we're using x, let's switch c to x and make it x squared. Okay? Now 24 squared is equal to 576. 30 squared is equal to 900. And then we don't know what x is, so let's keep it as x squared. When you add 576 plus 900, you get 1,476 equals x squared. And then to solve for x, remember you have to do the opposite, which is take the square root. So x is equal to approximately 38.4 inches. Okay? But we're not done yet. We just solved for this, which is equal to 48, excuse me. And I'm going to change the direction of the equal sign, so equals 38.4. So now that we know this is 38.4, we know this is 18 inches, we can then solve for the hypotenuse, which is the longest stick that will fit inside this box, and we also have called it y. So I'm going to bust out the Pythagorean theorem again. So a squared plus b squared equals c squared. In this case, let's make a 38.4 inches squared plus b squared, and b is 18, so 18 squared equals c squared. Now we know what 38.4 squared is because we just took the square root of this number. So 38.4 squared, going backwards, is 1,476. 18 squared is 324. And we don't know what c squared is, but we are using y to represent it, so I'm going to do y squared. When you add 1,476 plus 324, you get 1,800. And that equals to y squared. To solve for y, or to get y by itself, we got to do the opposite. So the opposite of square is square root. Take the square root of that, and the square root of 1,800. If you do it on your calculator, you get about 42.4. So the longest stick that fits in the box, or the length of the longest stick, is about 42.4 inches long. Okay? So now I feel like you have all the skills you need to be able to try the last math section in the packet, which starts on page 31. And if you notice, this is a problem that I just did. And then it starts here, number 1, number 2, number 3. And then it goes on here, and on your packet, but not on this one, there are some circled ones, so I want you to try the circled ones. Okay? And that concludes our YouTube lesson for today, but if you have any questions, feel free to email me. I will be checking my email throughout break. I don't know if I'll be checking it every day, but I'll be checking it once in a while, so maybe I'll be able to get back to you and respond to any questions that you may have. Okay? Packet is due when you come back from break. Good luck and happy Thanksgiving.